Okay, so a few things. If we want to arrange n objects, right? If we're arranging n objects, there's n factorial ways to do that. And whenever we talk about a arrangement, that's a permutation. Permutations and arrangements occur only when what happens? No, what do we assume? No repeats. Okay, so we can have repeats. No repeats. Now today's lesson we're going to look at a very different, similar situations to yesterday, except for what if there is a repeat of letters? How do we deal with that? But we still want to arrange these objects. So for example, if we consider looking at bike, there's 4 letters in the word bike, and notice there's 4 factorial ways to arrange it, or 24, 6 times 4, or 24 ways to arrange the word bike. How about arranging the word book? Is one O distinguishable from the other O? Distinguishable means, can you tell them apart? Are they different? No, if I switch these two O's, would we still have the same word, so to speak? Yes, we would. So how many ways are there to arrange book? How many do you count? You count 12, okay? There's 12 ways. Well, what happened? Well, notice that there, in each one of them, if this was another letter, if I had like an I instead of this O, one of the O's, right, these two could be switched. So there's half as many permutations. What if I had B, you don't have to write all of those down, okay? What if I had B-O-O-O, boo, okay? How many ways to arrange that? So do you think there'd be if you make a guess, how many do you think would there be? Okay, you think there'd be 6. So we did divided this by 2 before. Are we dividing it by 3, or what's going on? Let's take a look. Okay, so we could do this. What's another arrangement for those letters? We had to make another word. O-B, O-O, what else? O-O-B-O, and last, O-O-O-B. Is there any other ones? No, there was just 4 ways. Okay, so notice that the letters O-O-O, if I was arranging 3 objects, there's normally 3 factorial ways to do that. Notice that it was 24 divided by 6. It was actually 1/6 the amount of the original. Does anyone know what factorial equals 6? 3 factorial, yeah, 4 factorial over 3 factorial, because if these were 3 letters, normally to arrange 3 letters is 3 factorial ways. And so we have to divide out those 3 factorial. Or notice that this was 24 divided by 2, or 4 factorial over, what factorial gives us 2? 2 factorial, because we had 2 O's that were repeats. So today we're going to deal with arranging of objects when some objects are identical. Okay, they are not distinguishable. So notice there are fewer permutations, obviously, because we can't distinguish between B-O-O-K and switching the O's, B-O-O-K, those are the same thing. So we're going to have fewer permutations. And how do we find how many arrangements? Well, why does this happen? This happens because some of the objects in the set are identical. And so we're going to have fewer. And it's quite simple. So the number of permutations of n objects where A are identical, another B are identical, another C are identical, would be n factorial over A factorial, B factorial, C factorial. So that would be your repeats. Let me give you an example. Let's say red deer was one word altogether. I think is it separated or is it one? I think it's separated, right? Normally? Let's say that's one word. So how many letters here do we have? Total of 7 letters. So 7 factorial. If I were to arrange just 7 letters, it'd be 7 factorial. However, how many E's or let's start with R's. How many R's do we have? 2. So if these were switched, they would be the same. They're not distinguishable. So 2 factorial, how many e's do we have? 3 factorial, and how many d's do we have? 2. Okay, so we divide by the repeats. Because we have 2 r's, 3 e's, and 2 d's, you have to divide by the repeats to actually eliminate those ones that aren't distinguishable. How would you enter that in your calculator? What would you need, actually, is really the key word I'm asking. Brackets on the bottom, yeah. So 7 math left arrow 4 divided by, if you know these smaller factorials, it's so much faster. What is 2 factorial? It would be 2 times 1, so just 2. What's 3 factorial equal to? 3 times 2 times 1, so 6. And then 2 factorial is just 2. So if you know these smaller factorials, it makes it a lot faster to enter in your calculator, because every time you have to go math, left arrow 4, right? It's kind of can be a pain. It'll give you the same answer. I mean, you can get pretty fast at it. And 2. But it can, I don't know, 2 times 6 times 2 is a lot faster, I think. So 210 ways. For example, the set of 4 objects, A, B, B, can be arranged 6 different ways. And the list of them are down below, right? Because A and B are not A and A. The 2 A's are not distinguishable. And the 2 B's are not distinguishable. All right, so I think this lesson will be pretty quick. Turn the page. So dividing n factorial by a factorial, b factorial, c factorial, and so on deals with the effects of repetition caused by the objects that are identical. Okay, so please put those in your calculator and evaluate those two. Make sure you can type that in properly. Make sure your busy brackets are there. And you'll notice that beside a factorial, you actually don't have to write the multiplication sign. It will automatically multiply it for you. Nope, it gives you the same thing. So if I go insert times 2 factorial, same, 420. Or some of you might have gone 7 factorial divided by 3 factorial is 6 times 2 factorial is 2. 420. Okay, 420. And 8 factorial. 8 math, left arrow 4. Divided by, instead of writing 2 factorial times 2 factorial times 2 factorial, what could you type in? 2 times 2 times 2, right? 2 times 1 is just 2. 5,040 ways or arrangements. So even if we have restrictions, so we were arranging something and there's other restrictions other than the identical objects, we can figure out how many total arrangements we normally would do and then divide by our repeats in the end. And we'll get our final answer. So in the let's look at this one. In the mountainous region of India, China, Nepal, and Bhutan, did I say that right? Probably not. It's common to see prayer flags. Each flag has a prayer written on it, and a color is used to symbolize different elements. So green is water, yellow earth, white is air, wind, blue sky, space, and red is fire. How many different arrangements of the same prayer can you make with these 9 flags? So you have 1 green, 1 yellow, 2 white, 3 blue, and 2 red. So how many objects are we arranging first? 9, okay? So we have 9 factorial. If we want to arrange n objects, it's n factorial. So we're arranging 9, all 9 of them. So we don't have to worry about dashes. We're not arranging only a few of these, okay? divided by, where are my repeats? What are my repeats here? Third. Which ones are repeating? White, blue, and red. If I divide by 1 factorial, that's just 1. So that we only need to divide by our repeats. So we have 2 white. We're going to divide by 2 factorial. 3 blue, 3 factorial, and 2 red, 2 factorial. So those are my repeats. When you type this in, don't forget your brackets for the bottom. And 2 times 6 times 2, or you can type in your factorials. And there should be 15,120 arrangements. Okay. All right, we're going fast today. I might throw in an extra question. Okay, how many ways can the word Canada be arranged if the first letter must be an N and the last letter must be a C? So we have some extra restrictions, not just the repeats. Okay, which letter is repeating here? In Canada, it's good old A. A. Maybe that's why we always say A. I don't know. Anyways, so we deal with our problem how we normally deal with it yesterday. So if I'm arranging, how many letters are there? Make sure there's 6. Let's do our 6 dashes. And why do I want to do 6 dashes here? Because there's certain restrictions on certain positions. Okay? We're not just arranging 6 factorial this time, all 6 letters. Because what restrictions remain? What do we have to add in here? Is there any restrictions on any of the positions? The first letter must be an N. So we're going to write an N in there. It's supposed to be an N. And the last letter must be C. So we're going to deal with this as if it's just a regular problem before we worry about repeats. How many N's do I have to choose from? 1. There's only 1 N. And then we go to our other restriction. Always do your restrictions first. How many C's do I have to choose from? If there's 2 C's, I would literally write 2. But how many C's are there? 1. Okay? So now, how many letters remain to put in this position, the second letter? There's 4, then 3, then 2, then 1. So we're arranging as if all the letters are distinct to start off, as if they're all different. Okay? Or they're like our car problem. And then we will divide by our repeats. So we'll take this solution, divide by our repeats. Okay? So this is the same thing as, what is that equal to? Another way we could write this. 4 factorial. Okay? And then divided by, now we divide by our repeats. Which letter is repeating? And how many times? 3 times. 3 factorial. Okay? So this is where the repeats of A. So we arrange it normally with our restrictions like we did yesterday, and then if there is a repeat, we divide by the factorial of our repeats. What's 4 factorial divided by 3 factorial equal to? 4. We could probably come up with the arrangements ourselves, but there's only 4 of them, right? Do you want to do that? No? It's not that hard, but right? Like there's 3 A's. So A, and the other letter is D, and then ends in C. And so then this, you could have A, D, A, or you could have A, D, A, C, or D, and then 3 A's. Why is it 4 factorial? Well, just the 4 times 3 times 2 times 1 is 4 factorial. Times 1 times 1 can be just written as 4 factorial. Yeah, or you could just multiply these out if you like and get 24. Divide by, because there's a repeating of A. Yeah. All right. Julie's home. These are kind of fun. We looked at these if you were in Math 20-2. You've seen these before. I'm going to show you two ways to solve them. We only had one way last year. We're going to start with that way, and then I'm going to show you another way using permutations to solve this problem, and repeats. Because we can kind of think as your movements as a word. So let's start off with one way to solve. If you're starting at school, and Julie is, and Julie wants to go home. Okay, she wants to go to her house, I believe, right? Yes. How many routes can Julie take from home to school? Sorry, she's going to school. She's leaving her house. So if you think about where she is right now, every time she moves, right, we have to think about pathways. How many pathways to each spot to get to our final school? So if we start very small, how many ways are there to get to that spot right there? If she can only move, that would be, what direction is this, east or south? So she can only move right or down. So there's only one way to get there, right? Because you can't go back down and then back up again. You want the quickest route. We don't want direct routes. This position here, how many ways? It would also be one, right? Because she can't go down and back up, we always want to move closer to school. How about this position here? How many ways? It would also be one. There's just one way to get there, right? Because you can only move right or down. So my question to you is, how many ways is there to get to this corner right there? Two, right? She could take this way, this route, or she could go down, so she can go right and then down, or down then right. So there's two ways. Okay, how about this spot here? How many ways to get to this spot? If you can only move down and right, well, only one way. You can only go straight down. So all those across are one route. They're all one route to get that, because she can only move right and down. So here. Now what about this spot here? How many ways can she get to this spot right there? Okay, well, let's think. Let's try something. I'm going to grab a highlighter. So we can go, I can go that way. That's one. Two down and one right. We could go down, right, down. Or is there another way? She can go right and then down. So how many ways was that? Three. Three ways. Do you see a correlation to these numbers? If there is one way to get to this spot and two ways to get here, then to get to this next spot, we have a total of two ways to get there, plus the one way to get there gives us a total of three. We can add those up. The bottom would be 4. Okay, what would be this one right here? If you're adding up your diagonals, the two that are feeding into it would be 3. This guy would be just an adding game now, right? You want to fill in the rest or do it together? So if there's 3 ways coming from that block, 3 ways coming from that block, I now have a total of 6 pathways to that corner. And 6 and 4 gives you 10. So we fill in the rest. We just keep going until we get to school. So 1 and 3 gives you 4. 6 and 4 is 10. 10 and 10 is 20. So fill in the rest and see how many you get when you get to school. Finish the boxes off. Okay? Yeah, good. So this is 5, right? 1 and 4. Okay, so you should get to 56. Did you get to 56? Yeah? Okay, so that's one way to solve the problem. Another way is, if we think of east and south, right? She has to move how many east? 1, 2, 3, 4, 5. So she's going to move east 5 times, and she's going to move south 1, 2, 3 times. So we can think of it as a word that we are arranging. We are arranging the word east, east, east. So 5 east and 3 south. That's the word we want to arrange. Because we can go east and south in different orders, and that makes a different pathway. So if I have like this is one arrangement. If I go east, 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 south, south, south. Another arrangement, I could have south, 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 and then the rest east. That's another pathway. So how do we arrange a word with 9 letters? Well, how many letters are there? How many movements does she have to make? 9 factorial, so 9. Is that 9? I think that's 8. That's 8. Then, what do we have to do? Divide by our repeats. If this is the word we're trying to arrange, so our repeats, we have 5 e's, 5 e's, 5 factorial, 3 factorial for our 3 souths. Because if I arrange a word, if I had like east, south, east, south, east, and then south, east, east, that would be a whole different pathway, right? Than the first one. Oops, there's a highlighter. So if I did that, east, south, east, south, east, south, east, east. That's one pathway, right? And we want to divide by repeats because you want it distinguishable. So what's 8 factorial divided by 5 factorial, 3 factorial? Let's try that. 8 math 4 divided by bracket 5, oops, math 4, nope, math arrow 4. And then 3 factorial is 6. And that's 56 ways, which I think is a lot easier, but both are great ways to solve the problem, okay? 5 pathways. Okay, so your homework is, can you all grab your workbooks and open up to page 35? I'm going to omit one of the questions. I think it's number 5, but let me just open it up with you. Oh, it's opening up on the wrong screen, sorry. So the pathway problem, on your diploma, you won't have pathways like this one, number 5. So you can omit number 5, okay? So omit number 5 from this one, because, so number 4 is fine, okay? But pathways like number 5, where it's like changing, you won't have that on your diploma. It would more be a direct route. Okay, so you can omit 5 on your homework. The solutions are on the website, as you can see. They should be up. And we have the rest of class to work on it. And if you have questions, please ask, okay?